side of the screen. One screen. The third one is for sharing your presentation file.
Ini gimana? Buka.
Oh, itu yang orang lain yang sharing.
Kita punya gimana?
Betul.
Saya di sini juga.
Ada kan?
Itu punya Bapak juga?
Enggak, bukan. Saya belum masih dikasih saya ininya. Ini ya. Tadi ini.
Kasih akses sekarang ya.
Udah. Whiteboard. Share.
하나는 다 줘버렸어요. 다 줬을 때 전부 다 줬다. 전부 다 된다.
Saya udah buka sebenarnya di dalam. Sekarang kita buka ini ya. Ini di drag ke. Oh. Ini di drag yang di sini.
공중지.
Enggak, itu bukan. Saya belum kirim ke mereka. Ini di drag ke.
Yang share bukan.
Jadi buka share dulu. Ini dulu ya.
Please send me your slide. Please send me your slide. I'll upload.
Send my file to you?
Yes.
To your email or to your WhatsApp?
WhatsApp or email.
WhatsApp or email. Okay, I will send it.
Okay.
팍이라는 게 원래 뭐 썰 이런 개념인가요?
미스터.
아, 미스터.
Kalau kita mau lama jadi udah, ini kan udah stigma dua tingginya, ini kan bisa langsung eksploitasi aja.
Bagus. She's not coming yet. Oh no. Yes. 없는 중에 뭐 하셨어요? 됐어요? 보이세요 저거? 저 화면 보이시죠? 네. Okay. Still we have waiting somebody from the project management unit of good side and some POPR. 지금 여기 진행자라고 나와 있는 게 엄 박사님이 나와 있나 보네.
전부 다 나요. 전부 다 진행자들은
오케이.
전부 진행자들만 그렇기 때문에 전부 다 그냥 공유할 수 있어요.
Paeo, I have sent you via WhatsApp to you, Paeo.
Okay.
I sent my presentation file.
Dr. You find it?
좋았어요.
Wait a minute.
Sorry, Paeo, because I don't have your number.
Okay, no problem, no
You
problem.
can use our PMU team chatting window.
Oh ya, di ini ada ya, di Bentar ya, boleh sih. Sudah 1:20. Oh belum, mau mulai?
13.98
Mau mulai ya?
Oops.
Memang layarnya agak di bawah ini.
Ini ke bawahin dikit ada ganjel di bawah. Saya tadi narik kursi ini naik.
What's it there?
Emang bisa arahin kamera ke bawah?
Enggak sih kok di sini masih
Oh, udah diganjel.
udah full ya.
Bisa juga sih diganjel lagi. Iya ya. Baik-baik aja ya.
Ya,
Tapi nanti makin bacanya bisa. Ya, sekarang harus dibuka. Sebelahnya aja ya.
tapi takutnya malah di share screen nih Pak. Nah, yang sampingnya takut di share screen.
Enggak.
Nanti kan kalau share screen takutnya semua tampilan itu Pak.
Kan udah saya kirim filenya ya kan.
Oh iya.
Kan saya akan udah saya kirim tadi dia minta dikirim.
Oh,
Yang share dia kayaknya.
kalau gitu.
Tapi nggak tahu komandonya geser-gesernya biasanya kan kita yang tahu. Satu bisa dari sini biasanya.
Enggak apa paling next.
Nextnya gimana? Oh, minta mereka. Ketinggian ini ya.
Bakus has a little trouble to connect to this. 이메일로 보내달래. 아유 씨.
유교수님 안녕하세요.
예, 안녕하세요. 예.
지금도 사실 조금 좀 죄송한데 그 여기 토론자 네덜란드에서 오는 사람이 이게 링크를 다시 보내달라고 그래갖고 그것 때문에 지금 시작을 못하고 있습니다. 좀 기다리셔야 될 것 같습니다. 박 윌리엄? Hello, 박 윌리엄? 지금 안 되나? Can you hear me, 박 윌리엄? Oh, Mr. John. Hello. Selamat siang. Okay, I think it's almost time to start our session. Okay. Good afternoon, ladies and gentlemen. Selamat siang, Pak William dan Pak Gus. Maybe he's not yet here. Ini semua Bapak dan Ibu from the Indonesia. I would like to welcome all of you here today. And I'm very much honored to moderate today's meeting, inside the project, and inside the special session in Smart Water Grid International Conference 2020. Also, I would like to express great appreciation to the conference organizer for inviting us to allow coordinate this special session. Okay, now let's get down to our own business. Today's meeting is about basic design on NCICD Outer Sea Dike and flood in Jakarta. The objectives of today's session are to share the outcomes and the findings of a Korea team on the feasibility study and basic design for NCIC Stage B, Outer Sea Dike, which is Outer Sea Dike, with Smart Water Grid members and experts. And also, the second objective is to exchange knowledge and views on how to defend low-lying coastal region from the flood, and how to develop and manage the coastal area, including water resources engineering and water quality, etc. The session will start with a presentation on integrated flood safety plan for NCIC Stage B by Dr. Myung-chul. He has served as project manager of Korea team of consultants for NCIC projects. The major work scope of a Korea team is the feasibility study and pre-design for NCIC Outer Sea Dike. The second presentation will be given by Mr. Park Moon-hyun. The topic is flood mitigation for NCIC program. He has been responsible for design flood analysis and the recommendations on flood mitigation for the project. As everybody may recognize, this session is allowed on about one hour of 20 minutes and a little time constraint. So I would like to remind each presenter having only 15 minutes for the presentation. Right after the two presentations from Mr. Ong and Mr. Park, I would like to invite the four experts for the designated panel discussion. They are Pak William from Indonesia, and Pak Gus from the Netherlands, Professor Song In Hong, Seoul National University, and Dr. Kim Chang-wan, the representative of H2R Incorporated from Korea. So two the discussants from the Indonesia and the Netherlands, and two from Korea. Pak William was the director of PUSAIR, which is a leading research institute of the Ministry of Public Works and Housing, Government of Indonesia. He is a very well-known, internationally well-known researcher in hydrological study and flood analysis. Mr. Kus is the principal advisor to PMU NCISD program, and he has contributed very actively in the international water-related program and events, and including that World of Water Forum and UN activities or something. Any question and comments during the session are welcomed. If somebody wants to raise questions and comments, please use that computer. Just click the button for chatting room on the room screen of your computer. You can use that at the chatting room for any questions if you want. And also for Korean participants, you can use that Korean language for that the questions and comments, and then I will collect them and try to pass them over to the presenters and discussants for that. Okay, let's start with the first speaker, Dr. Are you ready?
Thank you, Mr. Chairman. Just a moment, I'll share my screen to you.
Okay, still not here. Maybe he has trouble.
It takes some time to upload.
Today we are going to two presentations, and then after that, we are going to take questions and comments from the floor. But during the presentation, if somebody wants to raise the questions, just use that chatting room on the screen.
I'm sorry, connection problem happened, so it takes some time to upload my.
Okay, no problem. No problem. Take it easy. Hello, Dr. Yukihi. Hello, Dr. Yukihi.
Yeah, nice to meet you, all of the experts. So I'm very happy to hear about the findings of the FS of the very challenging project in Indonesia. Thank you for inviting me.
Oh, you're welcome. It's a long time. No see you. Okay. What about Mr. Jung Sung-young? You here? Can you hear me, Mr. Jung Sung-young? Oh, maybe not. Well, sometimes there's a very high and mix. Oh, well, it's okay. Good. Thank you.
I'm sorry to have some connection problem. Thank you, Mr. Chairman. Good afternoon, everybody. As I already introduced by Mr. Chairman, I am Myung-chul, Korean consultant to NCISD program of Indonesia. Now, I would like to present you the concept of NCISD program, especially for flood safety plan with out sea dike in Jakarta. We call out sea dike as OSD. NCISD means national capital integrated coastal development in Indonesia. Jakarta, the capital city of Indonesia, is located in western part of Java Island of Indonesia. The project area of NCICT is the northern coastal of Jakarta, the capital city of Indonesia. Jakarta coast suffered from frequent flooding, not only from the sea flood in red color, but also from river flood in blue color in this picture. The main cause of these floodings is land subsidence due to excessive groundwater extraction in Jakarta city. Land subsidence rate in coastal area reach nearly 5 to 10 centimeters per year. The land subsidence in western part of coast is much severer than eastern part. In addition, low safety level of coastal dike and reef dikes made the situation worse. It means the flood occur everywhere or every 10 years. If land subsidence continues with current rate, most of coastal zones of Jakarta in blue color in this figure will be placed under the sea level. As a result, almost 20% of Jakarta area, or 2.4 million people, will be affected and vulnerable to frequent floods. After extreme flood of 2007 in Jakarta, some flood protection strategies were made by Indonesian government. In 2012, Jakarta Coastal Defense Strategy, or JCDS. In 2014, NCICT Master Plan was developed in cooperation with the Netherlands. Based on these strategies, we have developed conceptual design on NCICT, integrated flood safety plan, and preliminary design on OpenOSD. For developing NCICT further, trilateral cooperation was made between Indonesian government, Korea, and Netherlands. The cooperation work of NCICT will be implemented by the end of this year. It includes design of stage A, making outline business case on stage B, and design on stage C. Korea consultant team is providing preliminary design and land development and financial plan on out the sea dike of stage B. Meanwhile, the design for stage A was provided by the consultant. Design on stage C will be implemented in the near future. The work of stage B mainly deals with preliminary design on out the sea dike of stage B. In addition, water quality improvement measures and flood control measures were provided. We also prepare land reclamation and business plan to provide funding source for OSD construction. Starting point of flood safety plan is no regret flood protection. It includes reduction of land subsidence, improving sanitation in Jakarta, and coastal dike improvement of stage A, and new construction of out the sea dike stage B and out the sea dike stage C. It also includes integrated land development to generate revenues for OSD. To build concept of out the sea dike in NCICT, we held a lot of stakeholder meetings. Stakeholders' interests on OSD are flood safety, land subsidence, beachway, water quality improvement, mangrove conservation, road connection, and land development. Based on these demands, we assessed concept of OSD. Stage A is enhancement of current coastal dike. They are already designed and delivered to Indonesian government by Dutch consultant. It is divided into 10 clusters of 45-kilometer lengths of current coastal dike. In the design of Stage A, Dutch team provided new design strategy for 33 kilometers of coastal dike enhancement and 7 conceptual port designs. For the design on outer sea dike for Stage B and Stage C, we adopt open sea dike concept. Open sea dike can reduce wave height on coastal dike, so it can extend the lifetime of coastal dike of Stage A by 15 years until 2040. The outer sea dike will give 2 options. When open, the OSD provides additional protection to Stage A coastal dikes by reducing wave height. Meanwhile, when closed, the OSD will provide permanent protection of Jakarta. In addition, OSD also provides traffic connections and urban development opportunity. Open OSD can provide better water quality, fishing way, and preservation of mangrove along the coastal area. Meanwhile, closable OSD can provide low water supply and permanent flood safety. But compared to open OSD, closable OSD may cause difficulty in water quality management and difficulty in providing seaway and mangrove conservation. Due to uncertainty of land subsidence, we choose adaptive and stepwise approach of open OSD as a first step. If land subsidence still continue over lifespan of coastal dike, we will close the OSD with floodgate and pump stations. For designing on open OSD, we have considered several factors carefully. Open sea dike should reduce wave height effectively to extend the lifespan of Stage A. Toll road route should be provided to ease traffic congestion in the region. Seawater flushing should be maintained through wide open gaps in order to avoid water pollution in Jakarta Bay and to provide seaway to the fishermen. A total of 1,300 hectares of new land will be developed along OSD to finance OSD construction. The OSD alignment should consider the capacity of retention lake and pumping stations for the next stage of closure of Jakarta Bay. Let me introduce about pre-design on open out sea dike. The total length of open out sea dike will be 21 kilometers from west end to east end. It has 5 open gaps. A total of 3.4 kilometers is open to the sea water. At gap site, we will have 5 bridges. OSD load will be placed on upper parts of the dikes. It has 6 lanes and will be connected to western part of Tangerang and eastern part of Ancol and eastern part of Stage C toll road. Open out the sea dike will have rubber mound structures like this figure, which is already proven design across the world, including Korea, Japan, and the Netherlands over the past decades. Dike crest level is estimated to 6.8 to 9 meters. Main materials are sand and rock. For foundation treatment for soft bottom soil, average 10-meter depth of bottom area will be reinforced by plastic board drain and deep concrete mixing method, DCM. We are designing road and bridges on OSD. Road had 6 lanes, 4 lanes for toll road and 2 lanes for frontage road. 1,400 meters of long span bridges provide the clearance of 200 meters by 37 meters for container cargo ships. 4 bridges will have 600 meters of span. They will provide clearance of 50 meters by 30 meters for fishing boats under 200 tons. Small fishing boats in this region can pass these bridges. Open sea dike can reduce wave height effectively, nearly by 0.5 to 1.3 meters. It can extend the lifetime of coastal dike of stage A by 15 years until 2050. Open OSD can provide support to coastal area, so this mangrove forest area can be maintained. In addition, a total of 123 hectares of new mangrove planting is suggested near the current forest area. Through 5 open gaps, fishermen can access to Java Sea effectively. So, Jakarta Bay remains fishing area after construction, OSD construction. To avoid water pollution in retention lake after open OSD construction, 2 main countermeasures were suggested. The main measure is Jakarta sewerage treatment strategy. They should be implemented on schedule. Wastewater treatment plan is the most effective way to reduce source pollutant loss in Jakarta. Until 2030, before open OSD construction, 6 wastewater treatment plants will cover Jakarta sewerage treatment. The implementation should be intensively supervised by Indonesian central government. Wide open gaps of 3.4 kilometers of OSD will play important role avoiding water pollution in Jakarta Bay. For the urban development, 4 development zones was social residential area, commercial area for international use, and high-tech industry complex are suggested. The open sea, outer sea dike design with land development, mangrove, and the toll road matches the demand from the stakeholders, as well as providing effective flood safety. Thank you for attention. Thank you very much.
Okay. Thank you very much for your interesting presentation. And I think your presentation made the participants in this room understand more clearly what the insect development is, and also what kind of challenges the city of Jakarta has, how huge the insect project is, what do we need, and how to solve the problems, etc. Thank you again to Dr. An. And now I would like to invite the second speaker, Park Moon-hyun. You ready?
Yep. Thank you, Chairman.
Microphone is yours.
Chairman, I show my presentation.
still take time to upload your file. Okay. Mr. Park is going to talk about the river floods. I think there are two types of floods in Jakarta. Jakarta Bay is one is the river flood and the sea flood. But Mr. Park is going to talk about just the river flood. Please.
Thank you for briefing. Selamat siang and good afternoon. I am Park Moon-hyun, NCI-CD consultant. In this session, I would like to discuss on river management in Dakai, Jakarta with NCI-CD program. Dr. already explained the NCI-CD programs. Consist of stage A and open OSD and closable OSD. In this session, the main topic is related with closable OSD, not open OSD. For detailed issues, design flood of outer sea dike, flood mitigation effect, and several suggestions for flood management will be explained. Jakarta is located in the downstream of Ciliwung River Basin, and most part of Jakarta is low-lying area, so the city currently experiences three types of flood. The first is urban flood, which is due to localized heavy rainfall. The second is river flood due to high discharge by catchment-wide rainfall, and tidal flood, which is due to sea intrusion by land subsidence. NCI-CD program specifically deals with tidal flood. However, for permanent flood prevention in Dakai, Jakarta, it is most important to comprehensively manage all types of flood. After 1990s, Jakarta has been experiencing more frequent and serious flood. We can categorize the drivers of flooding into natural factors, human factors, and climate change. Natural factors are low-lying land and heavy rainfall, and the human factors such as urbanization, land subsidence, poor management have been exacerbating the flooding problems. Also, sea level rise and rainfall increase due to climate change will worsen the situation. Let's outlook flood-prone areas in Jakarta. Left side figures shows that low-lying area below mean sea level will continuously increase due to land subsidence as well as sea level rise. Centered and right side figures show the more low-lying area, the more river flooding areas. Especially combined with high tide, flood-prone area will increase seriously. From now on, I will explain how to estimate the design flood of the closable OSD, which is basis to determine optimal pumping capacity coupled with retention lake operation. In Jakarta, 15 rivers and drains flow into the Java Sea. Among these outlets, 9 outlets will be flowing into retention lake if OSD closed. The major outlets are Sengkareng Drain and Bekabe, which cover more than 80% inflow into retention lake. For an approach to design the flood of OSD, we consider the 4 factors. The first, sufficient flood safety has been considered by adopting 100-year of return period and reflecting historical maximum flood event, which is 2007 flood event of 11 days consecutive rainfalls. The second, upstream measures such as GY and Sugamai Dam diversion tunnel has been included in runoff analysis. The third, watershed development forecasting in the future has been projected for reflecting runoff increase by urbanization. The last, the design flood has been synchronized through the forecasted dike enhancement. As computational model, the Sobeng model was selected in cooperation with PUSAIR. This model has been developed by Delta in previous Jakarta flood studies. And now, PUSAIR is using and updating the model for various studies, such as flood forecasting for the drainage management. In the model, Chiliung River Basin has been divided into 449 sub-basins. Also, 22 wells, 32 orifices, and 33 pumping stations has been included. On these detailed hydrologic and hydraulic elements, the Sobeng model can calculate flood hydrograph and estimate flood inundation areas by two-dimensional modeling. Now I explain the procedure of designing flood of OSD step by step. The first, watershed development in future has been projected in runoff calculation. In hydrological aspect, urbanization will increase runoff due to decrease of permeable areas. In present conditions, total inflow into the retention rate by outlets is 1,780 cubic meter per second of peak flow and 507 million cubic meter of volume. By projection of urbanization in 2050, 6.4% increase of peak flow and 2.0% increase of flood volume is estimated. The second, upstream flood mitigation measures to dry dams and diversion tunnel have been included in the model, and the reduction effect of the measures have been evaluated. Left column in the table is the result of two dry dams, and the center column is the result of diversion tunnel only. And the right column is the result of considering both two dry dams and diversion tunnels. For the retention lake of OSD, diversion tunnel has more flood reduction of both peak and volume than two dry dams. The third, channel improvement scenario have been considered step by step. Scenario 1 means existing channel conditions, which has insufficient capacity, resulting in flow overtopping at most reaches. Scenario 2 means enhanced channel in major drains to prevent overtopping from northern Jakarta. Scenario 3 means all dikes are improved enough to prevent overtopping from basin-wide. But this scenario 3 is too ideal to adapt design value. Flood amount varies along channel improvement scenarios. 448 million cubic meter of volume in scenario 1, 461 million cubic meter in scenario 2, and 488 million cubic meter in scenario 3, depending on inundation amount in river basin. Comprehensively considering urbanization, upstream measures, and dike enhancement scenario, the flood with 1,358 cubic meter per second of peak flow and 461 million cubic meter of volume has been selected as the design flood of closable OSD. This flood has been used to calculate optimal pumping capacity coupled with retention lake operation. From now, I'll explain the flood mitigation effect by OSD. According to NCICD program's IFSP, Integrated Flood Safety Plan, the program has 3 stages. Immediate stage consists of coastal and river dike to protect the northern Jakarta from tidal flooding. This stage can protect the city until 2024. After that year, the city will be exposed again to tidal flooding risk due to land subsidence. Midterm stage is to build Opton OST, which will protect the city until 2050 from tidal flooding by reducing tidal height, but it has no effect on river and urban floodings. Long-term stage is to close OST for permanent protection from tidal flooding in case of continuous land subsidence. After close the OST, retention lake and pumping station will reduce the water level at the downstream areas. For the river and drains, flood water level will reduce up to more than 15 kilometers. Let's check the river flooding mitigation mechanism between upstream measures and closable OST. In Chirium River Basin, to the right dam at Upper Basin and the diversion tunnel to East Flood Canal at midstream is under construction. These measures will reduce flood water level at the mid and upstream area, but will have less effect downstream due to high boundary conditions by land subsidence and sea level rise, shown as left figures. Conversely, water level reduction in the retention lake of the closable OST can affect the water level at downstream of river and drains, shown as right figure. So, we estimated the river flood reduction effect closable OST and then suggested additional measures for comprehensive flood mitigation. Firstly, for Chenkareng drain, continuous land subsidence will make the drain to overtop more than a height of 2.06 meter in 2050 and 3.0 meter in 2080. You can see the blue lines in the figures. But closable OST will reduce the overtopping height up to 0.63 meter in 2050 and 1.38 meter in 2080. See the red lines. Without closable OST, Chenkareng drain will overflow seriously. So, more than 4 meter higher river dike shall be installed to prevent the city from flooding. However, the construction of the dike is not applicable due to densely developed area and high flood risk potential, which can cause tremendous inundations if the dike cracks. Secondly, for Bekabe West Flood Canal, continuous land subsidence will make the drain to overtop more than a height of 2.01 meter in downstream area in 2050 and 2.99 meter in 2080. You can see the blue lines in the figures. But closable OST will reduce overtopping heights up to 0.66. Also, in 1.4 meter in 2080. See the red lines. Bekabe appears to be not serious of flooding problem until 2050, except for some areas. However, in 2080s, if land subsidence may not stop, Bekabe may have difficulties against flooding without closable OST. Channel capacity means what amount of flood can flow in the channel without overtopping. The OST in 2018, 2050, 2080 respectively, and the lower figures shows the capacity on the closable OST. Without water level control by closable OST, the capacity of both Bekabe and Chenkareng will decrease, especially the decrease in the downstream will be serious. Otherwise, on the closable OST, the channel capacity will later increase in 2050 in spite of land subsidence, and will decrease a little in 2080 at limited reaches. For the flood mitigation effect, we also estimated inundation risk based on polder zones. According to RTRW 2030, 66 polders exist in Jakarta. Among these, 43 polders have been developed and 23 polders are under consideration. The risk of leachy polders was estimated by hydrodynamic calculation of Sobeng model into 3 categories. A zone, red color in figures, is high hazard polders with more than inundating height of 1.0 meter. B zone is moderate hazard polder. C zone, blue color, is low hazard polders. The number of zone A will increase on the open OSD in 2050 and 2080. But on the closable OSD, the number of zone A will not increase or increase a little in spite of land subsidence. Until now, I'll explain the flood mitigation effect in river and drains by closable OSD. NCICD program primarily focuses on tidal flooding by land subsidence, so it is not possible to solve all flood issues in Jakarta by NCICD program only. In respect of river flood management, synchronized with NCICD program, we suggest 4 key promotional strategies based on SWOT analysis. The first, establishment of strategy to turn crisis into opportunity. Second, respond to unfavorable natural conditions and poor management by implementing adaptation policy. Third, prevention of flooding due to land subsidence and mitigation of urban problems. Fourth, implementation of IFSP in order to respond to tide and river flood. How to manage river and drains in Jakarta linked with NCICD program. We suggest dike improvement, channel dredging, and hydraulic obstacle removals. Owing to jetty jump project, flow capacity of channels have been increased. However, in 2050, 56.4% reach of Cengkareng drain will have a flooding problem again by land subsidence. The closable OSD will not perfectly guarantee flood safety in rivers and drains, but reduce the flood risk. So, as additional action to increase flood safety, dike shall be improved up to design level linked with NCICD program. As well as dikes improvement, channel dredging will be effective at midstream. Channel subsidence will change longitudinal profile in the Cengkareng drains. Consequently, flow capacity in midstream will be reduced. The lowest black line in the figure means forecasted channel bottom level in 2050. And the lowest dot red line means additional channel dredging to improve capacity. The upper dot blue line is water level after dredging on the open OSD, and the upper dot red line is the water level after dredging on the closable OSD. Therefore, the combination of closable OSD and dredging along Cengkareng drains has a clearly positive effect on flood reduction from downstream to upstream, and will minimize additional dike hastening. 190 hydraulic obstacles such as bridges and pipelines are located in Cengkareng, Bekabe, and Ciliwung rivers. If the structures do not have enough clearance against flood flow, they can make serious problems such as water level rise and break. So structurally dangerous crossing should be checked and improved quickly. As a non-structural flood mitigation measure, the flood forecasting and warning system is an essential element in flood management. Jakarta Flood Early Warning System was developed with the support of the Netherlands, and the system is actively learning by relevant agencies such as PUSAID. But the system needs to be improved by expansion of hydrometric stations, forecasting system with capability of real-time operation linked with plausible OSD, as well as upstream measures under construction, and enough coverage of warning system extended to every flood-prone areas. Lastly, I suggest water management system linked with NCICD. Integrated with NCICD, water management system shall have real-time information monitoring, supporting tools for flood, land subsidence, water use, environment management, and information sharing with stakeholders shown as the figures. Thank you for listening my presentation. Terima kasih.
Okay, thank you very much, Mr. Park, for your very interesting and very excellent presentation on flood risk and flood analysis in Jakarta and how to mitigate the impact. Thank you very much again. Okay, ladies and gentlemen, we do not have gentlemen here, the ladies here, maybe. Okay, gentlemen, until now we have two presentations on pre-design of after SEDAIC from the Dr. and the flood analysis and mitigation effect from Mr. Park. For more effective discussion and better communication, two expert panels were designated and invited from Indonesia and the Netherlands, as I introduced at the opening of this session. Now I would like to invite Park William first. Okay, you ready, Park William?
Yep.
Okay, thank you. And the microphone is yours, please.
Okay. Thank you very much, Mr. Eodaisu. Ladies and gentlemen, not all gentlemen. Okay. First of all, I would like to say thank you to the presenters. First, to Mr. El Myung-Chu, who already gave us an excellent and nice presentation with the title Flood Safety Plan with Outer SEDAIC in NCICD program. And second, to Mr. Park Moon-hyun, who also already gave us an excellent and comprehensive presentation with the title River Flood Management in Jakarta with NCICD. For my comment and for my input to these two presentations, may I share my slide, Pak Eo?
Oh, sorry. Well, no, we do not have your presentation file here.
You already have? Now, can you see my slide?
No. We don't get. Well, actually, I asked you to send your presentation files, but I don't get it yet. Maybe you can try your computer too.
Mana? Yang mana? Yang di sini. Ini share ini. Ini udah. Oh, share.
You find that the button on your screen, left-hand side.
Ini. Can you get my screen? Ayo. You already have my slide?
Belum.
Belum?
Belum datang.
Belum datang? Ini kan di share. Ini apa nih? Share your screen, your entire screen.
Then I suggest what about change the order. And then
Pak Eo, you get? Do you have already my slide? I already screen share.
Oh,
Are you already? Okay, sorry.
all right, good, very good.
Okay. Can you see?
Yeah, I think it works.
Oh, okay. It works.
Try again. Try again. Thank you, Liam. Try again.
It's. Try again.
Yes.
aplikasi Windows.
Still in.
Coba minta dari sana.
You get my slide?
Not yet.
Oh, ya.
Not yet. Okay. Okay. I try it one more.
Yes.
You got it already?
You should click. I think you should click the screen share button.
Already. I click already screen share. Screen share.
One more enter.
One more.
Maybe that works.
Okay. Already?
Not what?
Not work?
No. Yeah. Konaka is there.
Okay, Pak Willy, I have a suggestion. Let's change all the discussion. But of course, to do the discussion from the Bakus. Is that okay for you? Oh, okay.
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 Bagus.
This is Bakus. Hello, Bakus, can you hear me? Very good.
Get already my sharing.
Oh, I don't see. I'm sorry, the inconvenience.
So ini. Oh, ini share lagi kan.
Oh, okay. Okay.
Working now?
Yes.
I think so. All right.
Okay,
Okay.
it's working?
Yeah. We can see your slide.
Okay.
This is mine.
Now, this is yours.
Okay then.
Yeah. Okay.
May I continue?
야, 하면 되겠네. 되겠어요. 이거 제 슬라이드 올린 것 같아.
May I continue?
But it's, okay, yeah, try.
Pak Eo,
Yeah,
may I continue?
sure.
Okay, thank you very much. So, ladies and gentlemen, concerning the first presentation with the title Flood Safety Plan with Outer Sea Dike in NCICD program by Mr. Eom Myung-chul, as Mr. Eom already said in his presentation, that we call the plan as IFSP 2019 or Integrated Flood Safety Plan 2019. Before IFSP 2019, actually we already have 3 previous plans, which we call the previous plan as DCDS 2012, NCICD Master Plan 2014, and updated Master Plan 2016. IFSP 2019 has been planned not only based on these 3 previous plans, but also from other previous plans that come from other institutions and stakeholders in Indonesia. The whole plan, including the IFSP 2019 that has been presented by Mr. Helm, in general consists of 3 phases, and we call it phase A, phase B, and phase C, as can be seen in the slide. Phase A is coastal and river dike or onshore dike, and phase B and C, west and east outer sea dike. The main differences between the previous plans and the IFSP 2019 are on how and when we build the outer sea dike or the offshore dike. In all previous plan, the outer sea dike, which means phase B and phase C, will be built as an optional flood control measure. Jadi phase B and phase C in all previous plans will be built as an optional flood control measure, which is depend on the land subsidence condition in the future, and will be built directly as a closed outer sea dike. That's for all previous plans. Meanwhile, in the IFSP 2019, the outer sea dike will be built in 2 stages. First stage, the outer sea dike will be built in adapting open outer sea dike. Jadi, first stage will be built as an open outer sea dike. The first stage, as outer sea dike become no regret flood control measure, or it is not an optional control measure, but no regret, that should be built. The second stage of this outer sea dike is to close the opening parts of the outer opening part of the outer sea dike, so that the open outer sea dike become closed outer sea dike. The second stage is an optional flood control measure. So in the IMSP 2019, for the first stage of phase B and C, that's a no regret measure, and for the second stage, when we close it, that's an optional flood control measure, and will be done if the land subsidence cannot be controlled or land subsidence continue. So another thing, in Mr. Eo's presentation, he is not present the criteria on when and how the decision should be made in order to implement or to construct the second stage of phase B and phase C. Probably the criteria will be presented in the overall long-term strategy IFSP 2020, which will be completed on 31st of December 2020. So we will wait for that, the overall strategy for that phase B and phase C. The phase A of IFSP 2019 is the 120 kilometer length of coastal and river dikes. The crest height of the phase A dike consists of some components, such as rate of land subsidence, tidal range, sea level rise, and extreme wave heights, as can be seen in this slide. For extreme wave height, 1.75 meter. That's depend on the location, but more or less 175 meters. And for the tidal range, 1.2 meter. Sea level rise, 0.12 meter. The main function of the first stage of phase B and C as an open outer sea dike is to reduce the wave height by 0.5 to 1.3 meter, so that the lifetime of phase A dikes can be extended by 10 to 15 meter, by 10 to 15 years. In this case, a question arises by many stakeholders. To extend the lifetime of phase A, why don't we redesign the phase A dike so that in the future the height of the phase A dike can be extended by 0.5 to 1.3 meter, depending on the location. This option probably more simple and lower cost compared to build a phase B and outer C dikes. Although we already answered all of these questions concerning this option, but the stakeholders raised this question. But anyway, that's the other opinion, that why don't we extended the height of the phase A dike to extend the lifetime instead of build the first stage of phase B and C. That's it. My other comment is concerning the title of the presentation. The title of the presentation is Flood Safety Plan with Outer Sea Dike in NCICT program. So this presentation should be explained more about how the outer sea dike can be functional as an integrated flood control measure, not only when the phase B and phase C as an open outer sea dike, but also when the phase B and phase C as a closed outer sea dike. What is the function? That I think we have to hear more concerning this one from the presenter. I think that all my opinion or comment for the first presentation. So can I continue for the second presentation, Pak Ayo?
Sure. Yes. Yes, please.
Okay. Concerning the second presentation with the title River Flood Management in Jakarta with NCICT by Mr. Pak Yun, his comprehensive presentation gave the participants more understanding concerning first type of flood and flood risk in Jakarta. Second, how he defined the design flood for Jakarta outer sea dike, especially when the outer sea dike has to be closed, or when we have to build the coastal reservoir in Jakarta Bay. Third, in his presentation, he presented how Jakarta outer sea dike will mitigate the floods in Jakarta. And fourth, he also presented the proposed guideline for river management in Jakarta and flood forecasting and warning system. And last, he also mentioned how water management system linked with the NCICT. Concerning the types of flood in Jakarta, I very agree with the presenter that in Jakarta, yes, there are three types of flood occur in Jakarta. First, as his presentation, urban flood, second, riverine flood, and third, tidal flood. And to be clearer and more understandable concerning the type of flood that usually occur in Jakarta and how the urban flood management in Jakarta, I will explain like this. There are three rivers flowing through Jakarta city and ended in Jakarta Bay. Most of the flood discharge of these rivers were cut and were collected by 4 flood drainage canals. This means Cengkareng flood canals, West flood canal number 15, East flood canal number 17, and Cakung Drain number 16. The flood water from these rivers will be drained directly to the Jakarta Bay by these 4 flood canals. In the flood canal in this picture is the red one, Cengkareng Drain, Banjir Kanal Barat or West Flood Canal, Cakung Drain, and East Flood Canal. In the capacity of these rivers, especially on the upper part of these four flood canals, and the canal itself are insufficient to drain the flood water from the upstream, it will cause the riverine flood, and the flood will inundate the flood-prone area. The Jakarta area with the whole catchment area can be seen in this figure. For the rainwater that fall in the downstream part of west and east flood canals in the picture, probably with the gray color. And if the local drainage in this area have insufficient capacity to drain the rainwater to Jakarta Bay, it will cause the urban flood or fluvial flood. And the third type of flood, coastal, the flood is a coastal tidal flood, the flood water that come from the sea. That's my explanation concerning the three types of flood which always occur in Jakarta. Concerning the design flood of the outer sea dike, I am very appreciative to the presenter, especially on how he defined and how he selected the design flood that is used as design parameter for open sea dike, especially when open sea dike should be closed and the flood water from the rivers have to be stored to the coastal reservoir and after that pump it to the sea. Although the design flood scenario that has been selected by presenter, in my opinion, is still debatable. When the presenter calculated the design flood, he considered not only the changing parameter of the rainfall-runoff relationship due to urbanization, land use change, and climate change, but he also considered the effect of flood control measures that have been planned and under construction, such as two dams in upstream part of the Ciliwung River and the diversion tunnel from Ciliwung River to the East Flood Canal. After he concerning about that I already explained, after that he makes three scenarios in terms of time frame. The first scenario is 2080-2050 with peak discharge 1,105 meter cubic per second. The second scenario with time frame 2050-2080 with peak discharge 1,358 meters per second. And the third scenario 2080 onward with the peak discharge 1,852 meter cubic per second. Finally, as in his presentation, he selected the 100-year design flood under the scenario 2050-2080 with the peak discharge 1,358 meter cubic per second. In his final selection, in my opinion, still debatable. Why he does not select the third scenario with peak discharge 1,852 meter cubic per second? This is based on the this is based with the optimistic thinking that in year 2050, Jakarta flood safety level for flood control measure already reached the 100-year return period for all riverine flood, which means no more riverine flooding by all enhanced rivers and drains. If we assume 2015 with no more riverine flooding, it means we have to select the third scenario, 2050 to 2080 onward with the peak discharge 1,852 meter cubic per second. That's about how he determine the flood that we use as a parameter. But the process when he concerning about the urban development, we concerning about the climate change, etc. I'm very appreciative for that one. And so another thing also concerning on how Jakarta outer sea dike will mitigate the flood in Jakarta. For his slide 12 of 24 on flood mitigation effect of NCICD, I agree for most of the statement in this matrix, especially for midterm and long-term time frame. However, in the immediate time frame, I have other opinion, especially coastal dike on fluvial flooding. The coastal dike in immediate time frame will also affect, especially in certain areas where have to be built the border system. This means no effect, but we have to outlet condition improve in polder. Jadi not only in the long term outlet condition improve in polder, but in immediate after we build the coastal dike, we also already concerned with the outlet condition to improve with the polder, because in this immediate stage, a lot of river can be drained directly to the sea because of the coastal dike. In this slide, when he present river flood mitigation mechanism, I agree with the presenter concerning the result of his analysis that upstream flood control measures such as Ciawi and Sukamahi Dam and as flood control will not affect up to downstream part. However, in my opinion, and also the result of our analysis, that no effect of this flood control measure in the downstream part are not only because of the high boundary condition by land subsidence and sea level rise, but also because in the middle and upstream ridges, it means before the flood come to the downstream part, a lot of insufficient channel capacity. So the water already overtops before the flood reaches the downstream part. That's why the two dams and one diversion canal doesn't affect to the downstream part, because before reach the downstream flood already overtops and inundated in the flood prone area. Concerning the key promotional strategy of flood, in which the presenter present the strategy through SWOT analysis, I also agree with the presenter. However, concerning to overcome the fund constraint, I will adding one opportunity. The opportunity is to get the funding through the integration of flood management with land development and transportation. So probably in his SWOT analysis should be add one more in the opportunity. Concerning the river management guidelines, he has presented a guideline how to manage the river in Jakarta, especially for Cengkareng Drain, West Flood Canal, and Ciliwung River. The river or flood canals should be managed in terms of river dike condition, dredging, and also removal of hydraulic obstacle as bridges, flood control gate, pipe, closed conduit, strata, etc. That I agree with all of that. He is right that the river dike in phase A only construct in the downstream area where the tidal flood may reach. In reality, the river dike in the upstream of tidal flood still has very low safety level, probably only 2 or 5 year safety level. So the safety level of the river dike in the middle and upstream part should be designed and synchronized with the flood safety level of MCICD. This means 100-year flood. That's why if we improve this one, we assume that 2050, all the riverine flood in Jakarta already covered by flood safety level 100-year return period. The river dike will also be heightening depend on the rate of land subsidence in the future. The river dike heightening can be reduced by maintenance shape of the channel by river dredging. Last one, his presentation is not only mentioned concerning the structural measure of flood control, he also mentioned non-structural measure to mitigate the damage caused by flood, such as flood forecasting and warning system and water management system linked with NCICD. He mentioned how to make flood forecasting and warning system in Jakarta shall be extended to every flood-prone area and has a capability of real-time operation. and also be linked with the closable outer sea dike and upstream and downstream flood control measures. That I fully agree with that one. Last thing of his presentation is in terms of smart water management to link water resource management system in Jakarta with NCICD with real-time water information management system combining variety of IoT and ICT to enhance stability, safety, efficiency in water resources management. That's all I agree. I think that's all my opinion or my comment on two presentations. Flood safety plan with outer sea dike in NCICD program presented by Mr. Elm, and river flood management in Jakarta with NCICD by Mr. Park. Okay, thank you very much. That's all, Dr. Eo. Give it back the time for you.
Okay, thank you very much for your thoughtful consideration and discussion on floods in Jakarta. Thank you again to Park William. But I don't know what it's the Park Om and Park Pang Mun Hyun summarize and his comments from the Park Williams, and I don't know how react on his comments. I think I will give you some time to summarize and think about the Park Williams comments. Okay, let's move on to the second the discussant, Bagus. It's my pleasure to. I'm sorry. Well, a pleasure to introduce Mr. Kus. As far as I know, he was one of the advisor to His Excellency King of the Netherlands, right? Willem-Alexander, in water-related issues, and he's a very well-known water expert in international arena. Okay, Kus, Bagus, the microphone is yours, please.
Thank you
Bagus?
very much, Mr. Eo. The line is very weak, so I hope you can hear me. And if I'm having connection problems, I will switch away at least my picture. Can you also move the slides for me? Go to the next one. You already introduced me. I'm in water management. I'm from Holland.
Okay, just 1 second. Okay, all right, good.
Yeah. I have a long history in water management. You already mentioned something. For me, it's very interesting that I had a lot of cooperation with Korean colleagues. Two of them are on this list in international organizations. When you look at this list, you will see that I'm more a policy expert than technical expert. And my role in NCICD is also then not on the technical issues, but especially on the policy elements and the political discussions. The next slide, please. Now, you already heard something about Jakarta Bay, and it's interesting. Jakarta Bay is well-known, notorious. We know all over the world. Everybody is talking about the fastest sinking city of the world, and yeah, there are many problems to be solved. There's a lot of attention from the international world, and there's already a long time. Are we working? You saw that in the presentations. We are working on flood programs and solutions for the flood problems. We have a lot of challenges: floods, drinking water in Jakarta, but also traffic congestion, slums, especially land subsidence. climate change, more rain, sea level rise maybe. Now, we need solutions for that, and NCICD is an integrated project. It's not only about building dikes, but we try to connect all those problems and solutions. And you can see here that apart from a coastal dike and an outer sea dike in our program, our project, we also are looking at land subsidence, drinking water provision, water quality aspects, and toll roads, land development, etc. So it's an integrated project. It's more than subsidence, than